In this lesson, I'm going to talk about pure endowment assurance. All right, and this is one of the easiest assurance. So if you can recall from the previous video, suppose you buy the policy at age X and the term is n years. So this is X plus n. So in order to get the benefit of this assurance, you have to survive this duration. Okay, and you'll get the benefit exactly at X plus n. So there is nothing called immediately or end of year. All right. So now the present value is when kx is less than n, we can say this is 0. Now if you remember the meaning of kx, this is the exact number of integer years a person will survive after age x. Okay, so here the kx is less than n, so it should be 0, right? Because the person has to survive until x plus n. Now when kx is less than or equal to n, the person will get the benefit and it will be discounted back by the discounting factor v to the power n. Or we can also use tx. We can also use tx because we are going to discount back at n, right? So it doesn't matter whether we use kx or tx. And if you remember, tx is the exact number of years including fractions that the person will survive after age x. Okay, so now tx is less than n, it should be 0, and tx is greater than or equal to n, this is v to the power n. All right, now expectation of the present value is, now you can also answer this from the logical reasoning that you have to survive until x plus n, right? So and then you'll get the benefit, so you'll basically discount back the n years and you have to survive, so the probability of surviving is npx. That's it. Okay, now you can also derive this from the mathematical calculations, that is going from the first principle. So let's look at that as well. Expectation of present value is summation k equals to n to infinity, then v to the power n and probability kx equals to k. Okay, we can take vn common, so vn summation k equals to n to infinity and the sum of the probability vn. Now we can write this as probability kx is greater than or equal to n. Okay, now what is this? The person will survive at least for n years, right? So we can write vn npx. So this is the expectation of present value. Okay, now we have an actuarial notation for this, axn, and there is a vertical dash on top of n. Or we can also write a bar x n and vertical bar. Now if you remember, this vertical bar is used in immediate case. Okay, when the death occurs immediately and the payment is made immediately, so this bar is used in the immediate case. Okay, and without bar, this notation is used in the end of year of death. All right, but now in this assurance, we do not have the immediate or end of year. Okay, so we can use both of these notations. All right, now let's see how we can derive the variance. So the variance of the present value, let's go with the basic idea, expectation of present value squared minus whole square of expectation of present value. So present value we know v n npx. Okay, expectation of the present value, so we can write v to n npx, and this is axn dash whole square. Okay, so this is variance of present value equals to, we have a notation for this, 2ax n dash minus ax n dash whole square. All right, and you can find these values in the table. I'll show you the table when we do questions in the later videos. Okay, for now you can just remember this. So this is all about pure endowment assurance. Now let's move on to the next assurance, that is endowment. Now if you remember, endowment is the mixture of term and pure endowment. Okay, so even if you survive, you'll get the money. If you die, you'll get the money. Okay, so let's do the first case, payable at the end of year of death. Okay, and the sum assured is 1 unit, and the person's age currently is X. All right, so let me help you recall what is endowment. So suppose you buy the policy at X and the term is n years, so X plus n. So if you die within this duration and the policy is end of year of death, then your nominee will get the money at the end of that year. Okay, and if you die at any point, then if the policy is immediately on death, then your nominee will get the money right at that moment. Okay, but now we are focusing on end of year of death. So suppose you die in between X plus 1 and X plus 2, so then your nominee will get the money at X plus 2. Okay, at the end. So now what is the present value in this case? Now this is the mixture of pure endowment and term assurance. So you can say when kx is less than n, this is v to the power kx plus 1, and when kx is less than or equal to n, this is simply vn. All right, now we can also derive the expectation by the sum of term and the pure endowment. So this is axn, this is term assurance, and axn, this is pure endowment. All right, and we have a notation for this, axn. All right, when there is one dash on top of x or n, then you can understand that is either term or pure endowment, and when there is no dash at all, then that is endowment simply. Okay, now you can also derive this from the first principle. What is this? The term assurance. Can we write k equals to 0, n minus 1, v to the power k plus 1, probability kx equals to k, and for this, for pure endowment, I can write summation k equals to n to infinity v and probability kx equals to k, right? And then you can derive this formula, you will simply get this value. Okay, now let's look at the variance. So the variance of the present value, again we are going to use the sum of present values of term and pure endowment. So I can write variance of the present value of term plus present value of pure endowment, and this will give me the variance of the endowment. So this is, now if you remember the formula of the variance, that is variance of x plus y is nothing but variance of x plus variance of y plus twice covariance of x y. Okay, so this is the formula of variance of x plus y. So now here, let me erase this. So variance of present value of term plus variance of present value of pure endowment plus 2 times covariance of these two present value. Okay, now we know the variance of term, variance of present value. We need to find out the covariance. So let's look at the covariance first. So the covariance Now again we have a formula for the covariance. If covariance of x y is asked, then this is expectation of xy minus expectation of x, expectation of y. Okay, so we are going to use this formula now. So this is expectation of present value minus expectation of each present values. Okay, now what is this term? We know the expectation of each present values, but what is the expectation of product of these present values? So if you remember, the present value of term is v to the power kx plus 1 when kx is less than n, and when kx is greater than or equal to n, this is simply 0. Multiply present value of pure, and this is nothing but 0 when kx is less than n, and when kx is greater than or equal to n, this is vn. So if you multiply this to present value, you will get, this is 0, right? This is simply 0, because this times this 0, this times this 0. Okay, so the expectation of this to present values is simply 0. So this is 0 minus, now what is the expectation of present value of term assurance? So this is ax dash n, right? Similarly for pure, axn dash on top of n. Okay, now we derive the covariance. So let's substitute in the variance. So variance of present value of endowment is, now here the variance of the present value of term is 2ax dash n, okay, minus ax dash n whole square, right? So this is the variance of the present value of term assurance, plus, now what is for the pure? 2ax, so this is x n dash minus ax n dash whole square. This is for the pure. Now minus, as you can see here, this is plus 2 covariance, right? And the covariance is negative. So this is negative 2ax dash n times ax dash. Okay, now let's simplify this little bit. We can keep this term and this term together. So this is 2ax dash n plus 2ax n dash. Now we can take common from these terms, and don't you think this is simply a plus b whole square? This is a square, okay, this is b square, and this is 2ab, right? So I can say this is minus a plus b whole square. Okay, now this is nothing but 2ax n minus axn. So these are the notations of endowment. Okay, this is term assurance and this is pure assurance, and the sum of term and pure is endowment. All right, so this is how you can derive the variance of the present value of endowment assurance. Now let's move on to payable immediately on death. So payable immediately on death. Okay, and we'll use the continuous random variable. So the present value is when tx is less than n, we can write v to the power tx and when tx is greater than or equal to n, this is simply vn. So now the expectation of the present value is, for this we can write 0 to n vt tpx mu x plus t. This is the pdf, okay, dt plus, now for this we can write n to infinity vn tpx mu x plus t dt. Now this is nothing but the term assurance, and this is pure. So we can write a bar x dash n plus, we can take a vn common from the integration, then this is probability tx greater than or equal to n, right? So now this is a bar x dash n plus vn to n, this is simply npx, and we can write this is nothing but the pure, so a bar x dash n plus ax n, okay, and we have a notation for this, a bar x n. All right, now let's look at the variance. And one more thing before we do variance, can we write a bar x n is equals to 1 plus I to the power 0.5 axn? Can we write this assuming the death occurs between birthdays? No, right? We cannot write this because it includes the pure endowment as well, and in pure endowment we do not have the concept of death, right? You have to survive to get the benefit, so we cannot write this. Instead we can write axn by separating the term and pure endowment. So we can write 1 plus I to the power 0.5, we can separate term, so this is term assurance plus pure endowment, okay. So this we can write, or we can simplify this, 1 plus I to the power 0.5 axn vn npx. All right, okay, now let's do the variance. Now you can basically guess the variance, you can derive on your own. I'm going to write the variance directly. So this will be 2a bar xn, okay. At this time this must be spontaneous, right, because you can guess all the notations. So this is minus a bar xn square. You can derive this from the first principle, that is expectation of present value square minus expectation of present value whole square, and you can basically do the calculations. You'll reach here. Now again, can we write 2a bar xn equals to 1 plus I 2axn? Can we write this? No, because again it includes the term and pure, and in pure we do not have death, okay, so we cannot write this. We can write by breaking the endowment into term and pure. So this is approximately equals to 1 plus I term assurance, so this is 2axn dash plus v to the power 2n npx. This is nothing but the pure, okay. So this is how you can derive the expectation of the present value and variance of the present value for endowment assurance. And in the next video we'll talk about the deferred assurance, okay. So I'll see you in the next video. Thank you so much for watching this video.